All right, today we are building the definitive blueprint for one of the toughest, most interesting roles in tech right now, the 2025 IoT Engineer. We're going to break down exactly what it takes to build those smart devices that are, completely reshaping our world, from the tiny silicon chip all the way up to the cloud.
But let's start with a question for you. When you hear IoT Engineer, what's the first thing that pops into your head? Is it like a hobbyist in their garage tinkering with a single circuit board? Because let me tell you, the reality of this job today, it's more like orchestrating a symphony of millions of devices, all on a global scale.
Yeah, the role has just evolved so dramatically. We've gone from that hobbyist building a single little proof of concept to an architect who's responsible for these massive, sprawling IoT deployments. It's not about making one light bulb turn on anymore. Nope, it's about managing millions of them securely and reliably out there in the real world. The scale is it's staggering. And the opportunity here, it is massive. We're talking about a market that's projected to grow at an annual rate of over 13% all the way through 2033. This isn't some niche little field anymore, right? This is a core pillar of our tech future. So, the big question is, how on earth do we make sense of all the skills you actually need?
Well, to tackle all that complexity, we're going to borrow a really powerful mental model from the world of strategy consulting. It's called MEES. It stands for Mutually Exclusive, Collectively Exhaustive. All that really means is it's a way to break down a problem with no gaps and no overlaps. It's going to be our secret weapon for building out this complete blueprint.
So here's our MEES blueprint. It's pretty straightforward. We're going to explore all the skills layer by layer. We'll start at the bottom with the physical device, then move up through the network and the edge, then into the cloud. And finally, we'll wrap it all up with the big guiding principles that hold the whole structure together.
All right, let's get building. Layer 1, the thing itself. This is the physical device, the absolute foundation of the entire system. It's where data is literally born from the real world.
Okay, so every single device has a brain. That's the microcontroller, or MCU. And this first choice you make, it's absolutely critical, because it basically dictates your entire development path. So what do? Do you go with the industry standard ARM Cortex-M and tap into its massive, proven ecosystem? Or do you embrace the open-source flexibility of RISC-V to build something totally custom? This isn't just a tech decision, you guys. It's a huge strategic one that's going to impact everything down the line. Now check this out, because it reveals a really crucial insight. Your choice of operating system, the RTOS, it's often dictated by your cloud provider. You don't just pick this software in a vacuum. It's more like you choose free RTOS because you're building for AWS. You pick Azure RTOS because you're deep in the Microsoft ecosystem. And that decision, made super early on, pretty much locks you into a specific development path.
Okay, but a device is pretty useless if it can't talk to anything, right? So layer 2 is all about weaving that network, giving the device its voice to communicate with the world.
So in the consumer world, the language is totally changing. I mean, for years you've had this problem, right? Your smart lock from one company couldn't talk to a light bulb from another, and it was just a fragmented mess. Well, Matter and Thread are the solution. Think of them as a universal translator, built on standard tech that's finally unifying the smart home. If you're an engineer in this space, understanding these protocols is absolutely non-negotiable.
So once you're connected, the next big choice is how the devices actually talk. And it's all about picking the right tool for the right job. You've got MQTT, which is like the reliable workhorse for most things. But say you've got a device on a really weak connection or a tiny little battery, that's when you pull out the lightweight CoAP. And if you're managing and updating a massive fleet of devices, well, there's a protocol purpose-built for that exact task, LM2M.
Okay, so our device is built and it's connected. Now it's time to move up the stack to the Cloud Command Center. This is the brain of the operation, where all that raw data from millions of devices gets transformed into real, valuable intelligence.
But here's a twist. Not all intelligence has to live in the cloud anymore. One of the biggest shifts we're seeing is something called tiny machine learning, or tiny ML, and it's all about putting AI directly on the device. The whole workflow is actually pretty simple in concept. You train a model, you shrink it down, like way down, and then you deploy it right onto the device itself. And what does that get you? Real-time decisions without ever having to send data to the cloud. It's a game changer. But using the cloud comes with a huge flashing warning sign. A few years ago, when Google just shut down its IoT Core service, it sent an absolute shockwave through the industry. Companies were left scrambling. The lesson from that whole mess is now crystal clear for every modern architect. You have got to avoid vendor lock-in. You have to plan for a multi-cloud world from day one, period. And the data itself, it's a totally different beast. See, IoT systems produce this relentless, non-stop stream of time-stamped measurements. Temperature at 10:01, pressure at 10:02, on and on and on. A normal, everyday database would just crumble under that kind of load. It can't handle it. That's why engineers use these specialized time series databases, TSDBs, that are built specifically to handle this fire hose of data. Okay, we're at our final layer, which, funny enough, isn't really a layer at all. These are the 3 guiding principles. Think of them like the pillars that have to support the entire structure. They need to be built into every single other layer we've talked about, from the hardware right up to the cloud.
So what are these pillars? They are security, operations, and business context. Security is pretty obvious. It's the system's armor. Operations is the plan to keep it all running, maintained, and updated for its entire life. And business context? That's its whole purpose for existing, the why behind it all. And let me be clear, without all 3 of these, even the most brilliant technical solution is basically worthless.
And let's talk about security for a second, because this is so important. In modern IoT, security is not an afterthought. It's not something you just sprinkle on at the end. It starts in the silicon itself. The whole concept is called a hardware root of trust, and it means there's a special secure chip whose only job is to protect the device's deepest secrets, its crypto keys, from the very first moment it ever powers on.
So here's the million-dollar question. How do you update millions of devices in the field without causing a total catastrophe? Because the old way was so risky, a single error could turn an expensive device into a useless brick. But the modern approach uses something called A/B partitions. It's kind of like having a backup engine. The new update installs on a separate inactive part of the memory. Then you swap to it. If anything goes wrong, anything at all, it instantly rolls back to the old version that you know works. It's a true failsafe for the physical world.
Okay, so we've laid out the entire technical blueprint. Now, let's bring it all back to you. How do you actually assemble these skills to build your career and, help build the future?
And here it is, the master blueprint for your career. On the left side, you've got the core skills. This is the foundation that every single IoT engineer absolutely needs. Then, on the right, you see the advanced specializations. This is where you can become a true, deep expert. Now look, the goal isn't to master everything here. That's impossible. The real goal is to build a strong foundation and then pick a specialty that really excites you. Are you fascinated by the idea of putting AI on tiny devices with tiny ML? Or are you all about making sure a device is unhackable from the moment it boots up with Secure Boot? That choice? That's your path to becoming truly indispensable.
And all of this leads to what's really the ideal career model for 2025. You want to become a T-shaped professional. That means you have broad knowledge across the whole stack, the top of the T, and deep, deep expertise in one area, the stem of the T. Or even better, become pie-shaped with deep expertise in 2 different areas. It's that combination of breadth and depth that makes an engineer truly, truly invaluable. So there you have it. The blueprint is right in front of you. It maps out one of the most exciting, most challenging, and honestly, most important fields in technology today. So the only real question left is, what part are you going to build?